Good afternoon. This is a presentation about space food system, and then this is a research done by me and one student from Brazil, and I would like that you appreciate the presentation. When we are talking about space food system, it's necessary to talk about some. Okay. Some initiatives just done in International Space Station, developed by some astronauts, no? And then one of the challenge to produce food in zero gravity is a uncommon development of the plants, no? And the zero gravity brings some damage to the development of the plants, as you can see here, the process of germination. Then the news is recently, NASA has announced the first fruit growing in Mars, or growing in International Space Station. In this case, was pepper for the first time now in July. And then we have some techniques to produce food, hydroponics, aeroponics too, and also the third option would be the aquaponics, the third option. And it's possible to see some experiments using the LED light to explore the photosynthesis of the plants. And then some cultivated foods in space were dwarf wheat, sunflower, Mizuna and red Roman lettuce, and also Chinese cabbage. And then this is one of the topics of exploration about how would be this kind of environments to produce food in space. What kind of greenhouse would be designed to produce different plants to provide food. And then some challenge about the food cultivation in space is rapid growth, considering non-gravity growth challenge, in this case in International Space Station. The food needs to be bring good levels of nutrients, and also presents elements of resistance and adaptability, and also presents characteristics, features about flavor. In this case, now we will be present some results about some learnings that you had from the operation of the Mars Research Analog Station in Brazil, Habitat Marte. Then we have here, Habitat Marte is based in Brazil. When we talk about Brazil, we heard a lot of things about the rainforest, but the rainforest is based in this area here, starting in Peru and Venezuela. But when we examine the different ecosystems in Brazil, you can see different kinds of landscapes. In this case, I live in this area here, and the corner of South America is a semi-arid region. Then you have some maps to show this region, okay, in the state of Rio Grande do Norte, we have a idea. In this area, I live in the city of Natal. It's wet, it's in the coast, but if you drive 60 miles to the countryside, it's semi-arid. We have a landscape with cactus in this region. Some problems like a low level of water. It's the temperature is around 67 Fahrenheit to 87 Fahrenheit, the average of temperature. When you talk about the food production, It's something of the interest of World Bank and some also governments around the world, because we have a full demand that will be increasing in 50%. We are from a population of 7 billion, we are going to a population of 9 billion. And then this creates a lot of challenges. It's also a pressure above the natural resources. No? Then we have a challenge about also the expansion of the world population. We have a pressure related with productivity, no? To feed 90 billion people in 2050. This is one of the great challenges about the food production. And at the same time, we have challenges related to adaptation, because we have a great threat to food production. Sometimes long droughts. Some studies of NASA is saying that now some countries will suffer not droughts of a year, but sometimes droughts of decades without rain. And then this would be a great threat to food production systems in many countries, and mainly in developing countries. And then this would bring a lot of problems. You know, sometimes wars between countries in disputes related with the food supply. And then would be presented like a landscape and inviting some new technologies related to produce food. In this case, we think that some technologies related to applied to space also would be applied to solve problems of climate change threats, and also problems related with food production levels. And then some solutions proposed by World Bank is related to, we have what is called climate smart agriculture. Is based in 3 pillars: is increased productivity, increased resilience, and lower emissions. Then, in our case in Brazil, in this area, as semi-arid region, we have some challenge because we have water scarcity, water reservoir collapse, a decade of drought, and also a ruin of economic activities. And then we have some rain during 3 months of the year, between February and May. But the heat, the evaporation is so high, and then this amount of water, more 2 or 3 months, we don't have more water because all the water was evaporated because the weather. No? And then this brings the motivations to operation of the Habitat Mart, that we are making a dialogue between a solution, a sustainability in space and a sustainability in semi-arid too. Here, there's a kind of the route to Habitat Mart is around 2 hours to arrive there from the capital. It's an image of the area. In this slide, you can see the main question: how research on space, sustainability, and semi-arid would be integrated. In this case, the proposal is to do this integration between sustainability and arid and semi-arid of the planet, and also the space. And then one important element, and try to create a circular space. In a circular space, in the United States, also called off-grid housing. We have the challenge to produce their own food, reuse of the sewage, the treatment of sewage to be used in food production. the use of renewables, solar panels, and also wind energy to microgeneration, and also a proposal of waste recycling, because we consider that in Mars, and this will be extremely necessary too. Then what we're doing there is connected with sustainable development goals. In this case, is a poor region, a poor area, a rural area, and then we are receiving students from public schools and try to invite them to think about solutions related with poverty and hunger. And also when we are talking about space and science in a region underdeveloping, we are bringing a quality education to them, and also inviting the participation of girls in this process, and also present opportunities of decent work, economic growth, innovation, reduction of inequalities. And in this case, we are glad to have the opportunity to present some of our results in some conference in Brazil, international conference too, showing what we're doing. And in this case, what is being doing in Brazil is very connected with our solutions is related with sustainable communities, responsible production, climate change and recycling, and also quality of life and sanitation. Because of some technologies that they are developing in Habitat Marte is related to filters, to recycle the sewage, and to be reused too. Some of these technologies would be shared to local communities in Brazil. In this case, one question is important is how to produce food in space habitats. I believe this is one of the main questions related with space habitat sustainability. When we're talking about space food production, it's more easy. We carry some seeds to be planted in space habitats. Instead, transport the prepared food or pre-prepared food. Then this research that we developed is describing some efforts that we had developed in the research station Habitat Marte in Brazil. In our case, we believe one of the main results that we have in Brazil is the development of some protocols related to food production. We developed, we had improved a routine related to operation of aquaponic system, also routine related with maintenance, also the food harvesting, also the process of the protocol to fish processing, also the protocol of observation of the condition of the biohabitat that is our greenhouse. Some challenge about food production systems is safe energy, crop surveillance, be autonomous managed. This is important because imagine a big greenhouse in Mars or Moon producing food. Sometimes it's difficult to a person because it's not big crews dealing with the food productions. In this case, it's very extremely important. We have automation and sometimes images technologies to analyze how the plant is growing, if you have some damage related to the plant growing, to have a good approach to this. Now, in this case, automation and technologies like Internet of Things and sensors and other technologies is very important to this. Other challenge is high and efficient production in limited areas. guarantee avoidance plagues, is important too. Adequate amount of nutrients to the plants. Sometimes, if you don't have a good controls, we can spend more nutrients than necessary, and you waste nutrients. Other aspect is maintenance, also is assembly, because in space habitats we need to consider how these equipments will be transported to space, and how the velocity to create these infrastructures, these facilities, and also existence of routines and procedures that we have spent a long time developing the procedures. Is also existence of guidelines, because we have different missions. If you look also the space analog research stations in Earth, and in all the cases we have different crews, in different times be part of the missions, and then we depict a new crew in a space analog research station. They need to know how is the operation, what kind of activities they need to do, what kind of procedure. Because of this, some space analog research stations in Earth, they had some problems with the food production, because sometimes a new crew, they don't have a correct guideline to operate the greenhouses. In this case, we will be presenting some history of food production habitat mart. Now we are only showing specifically the results found during the 2019. In March, we are connecting the energy and water to the biohabitat. This water was collected, is water rain, that were collected to be used in the biohabitat. In March, this image, we are concluding the infrastructure of the greenhouse. In April, we will be doing here what is called a grow bed, where is used to plant the crops. And then we are using some elements of automation to identify temperature, humidity, pluviometric levels, and fish ration activation. And then here in June, you can see the basil, the size of the basil. This basil is almost like 6 feet of size. And then in June, we consume the first lettuce produced in this greenhouse. And in August, we produced for the first time the pesto sauce, that was with pasta. Yes. And then this was a library to support, was also done during this year to support the activities in Mass Analog Research Station. In this image, we can see a little of the landscape with a lot of cactus in this area. It's very different from the image of rainforest. It's very completely different. And then the last mission was now in the beginning of October, and then we finished the operation of the organic waste treatment station. It's an area that we are treating the fish. It's not treating the fish inside the research station, but outside the infrastructure. And then we consume the fish for the first time. Here's the fillet of fish, the tilapia. And then here's the fish prepared with carrots, also garlic, and also basil in all the sauce.
So how much of the food on that plate was grown there at Untitled Chapter?
Now we have basil, pepper, and also lettuce.
Wow.
Yeah, and
zanahorias and carrots?
yeah, not carrots. These carrots we bring.
Okay.
But we also produce the fish. The fish in the water tank. And then one of our challenges is consume only the food produced in the system. This is one of our challenges maybe for the next year. Then it's necessary to expand the area of the cultivation, the greenhouse, have an expansion, because some plants, the root is bigger, and sometimes we need a different areas to cultivate some plants with bigger roots, and then we are thinking about this. And then in beginning like 3 weeks ago, we were consuming for the first time the fish produced in the Habitat Marte. Then we create a procedure about the processing of responsible processing of the fish. Then okay. In this image, we can see the greenhouse, and then inside this water tank we have the fish. And in this image, this water circulates to the grow beds, to cultivation of the food, and then the water returns to inside the water tank. In this case, we need to analyze the nitrate, also the pH and the ammonia, to control the levels, to examine if it's in good condition. We also examine the fish if they have some damage, because if parts of the fish, if it's damaged, would be a symptom of a kind of disease or not a good environment for them. And then these are we consider that we are doing in terms of routines about these procedures is very important that would be applied to space habitats, and also other analog space stations around the world. And then some results, some routines related with analysis, diagnosis, ensure the proper management of circular system, assure the fidelity of methodologies during the cultivation process, orientation for maintenance, detect possible failures to be fixed. And then in terms of conclusion, we are creating a database with physical and biochemical parameters, as temperature, humidity, levels of nitrogenous compounds, and pH of water. Okay, and we consider it's important to maintain the space food system. And then we are creating this database. We will have a long-term data about temperature, how this is changed during the year or during the seasons. And if some possible plagues that would affect the area of production too. In this case, our challenge is establish partnership with space agencies, space research groups to develop cooperative research, focusing about automation in Internet of Things sensors. That would be important technologies to support the food production. Here in this image, we have some students visiting and seeing the water tank and examining the plants. And then I believe these images synthesize what we are doing, because they can see that they are based in a semi-arid region with a low level of water during the year. But it's possible we have solutions for these areas. in lower levels of rain during the year, but have a good conditions in terms of the food production levels. In this image, you can see one of the fish that was consumed. Now here we have 900 grams or 1.3 pounds. In this case of tilapia, the useful part of the body is around at 30%. 30%. In this case, a fish of 600 grams, and we have like 240. No? In this case, it's necessary we consider the size. In this case, we consider these elements also to prepare the food to the crew. In this case, for one meal, for one analog astronaut, is one fish. We did some calculus about some considerations. We find this possibility. And then we are looking for some partnerships, like inviting everybody here to participate in Mars analog mission, have an activity in Brazil, northeast of Brazil. We also look for guidelines, donations, and also support email letters, some comments about what we are doing, because we'd like to share your comments about what we are doing in Brazil in some of our presentations too. No? And then we would like to show some 10 important elements that in terms of the advantage, we would be growing permanently fish and vegetables. We also would scheduling missions according to demands of a candidate, high commitment with publication of articles, student orientation, possibility of develop long-term experiments, low thermal amplitude, association of sustainable development goals, connection with community, reception of visitors from schools and universities, emphasis on circular economy, recycling precepts as part of the material are highly reusable, and attention priority in applied outcomes addressed to threats of climate change. Okay, and then this is my email, and my Twitter is Julio FD Rezende. You can follow me on Twitter too. If you have some cards, if there's someone interested in agriculture to apply to space, I'm very glad to talk about this. Thanks so much for your attention.